Welcome to another video of Simplified Shanto YouTube channel. In this video, I am going to show you one of the most useful tools of my workshop. This thing is going to save a lot of time for those of us regularly doing Arduino and electronics project. Whenever we buy a new module, sensor or other components, we usually first learn to use it using a breadboard setup where we need to do breadboard wiring, power distribution to each component, setting up display, setting input pull-up resistors, etc. Then we apply it to our main project. Besides, time and again we have to fix issues with some components separated from our main project like servo motor position tuning, component health checking, etc. All these things take a lot of time when we are to set up those usual connections on the breadboard. In this handmade circuit board, I have integrated all those frequently used components and required connections, which saves me a lot of time each time I attempt to use or troubleshoot a new component. Without further delay, let's get into the main video. First, we will look at all the components on this board. Firstly, you can see a Arduino Nano attached on a parallel rows of female pin headers. This works as a microcontroller we will use to get introduced to the new components and parts. Secondly, we have a OLED display attached to the female pin headers. This is internally connected to the Arduino Nano. Then there's those potentiometer which serves as input devices. There's input pull-up resistors connected to the analog pins for taking inputs from those potentiometers. If we don't need the potentiometer for our purpose, then we will have to simply detach this jumper from the pin header here. Then there's servo motor ports. 6 servo motors can be controlled individually from those 6 ports. Extra 2 ports behind each port are connected parallelly. That means we can control 3 servo motors using the same signal pin of Arduino. There's a voltage regulator with heatsink attached. This supplies power to those female pin headers and the servo motor ports. The leftmost and the middle black pin header serves as the common ground. The rightmost red pin header provides the output voltage of the voltage regulator IC, and the left red pin header is providing the input voltage which we get from this barrel jack. Besides, there's a significant amount of space empty on this usual size Vero board for any frequently used component I discover in the future. Now let's have a look at the connections behind. For that, we will have to unscrew those nuts and then remove this back cover. So I am starting to unscrew. The connection is pretty simple, though it looks a bit complex for those jumper wires. Firstly, the OLED display receives 5V power from the Arduino's 5V pin and the ground. Its SDL and SCL pins are connected to the Arduino's A4 and A5 pins respectively. Arduino receives power from this barrel jack to its VIN pin. Servo motors get power from the voltage regulator, which is actually parallelly distributed to those servo motor ports. Signal pins for each of these servo ports are connected to respective Arduino pins. Potentiometers also receive power from Arduino's 5V and ground pins. This has been done thus the fluctuating voltages after connecting the servo motors does not affect the reading of those potentiometers. The wiper pins of these 3 potentiometers are connected to Arduino's A0, A1 and A2 pins respectively. Another important feature of this board is that you can see the parts here are mostly detachable. That is, you can detach this Arduino Nano, also this OLED display and the voltage regulator. I have particularly made this because some parts might get damaged, or you might want some different voltage like 6V or 8V other than the 5V voltage regulator setup here. You may need this Arduino for different project or this OLED display, so I just made it on those female pin headers, thus I can easily replace them when I require it. Now, as we have get used to the components and connections of this board, let's move to a few use cases. The first use case we are going to demonstrate is its use as a servo tester. We will have to just upload the respective code and plug in the servo motors and power up the board using the barrel jack. Let's specify the pin. These three are connected in parallel, which are all the signal pin of the first servo motor. These three are all connected to parallel, which is the 5V output of this voltage regulator, and there's some parallel ground connections. Many a times we need to actually run servos in parallel for different joints, so I have kept 3 ports for a single servo signal. So I am going to connect one more motor in this port. Now our connections are done, so we are ready to upload the code. And here's the fun of the board. We just need to upload the code and all the basic circuitry are ready for us. I am not going to explain the code behind the servo motor because that's beyond the scope of this video. So let's power it up. I am using a 3S battery pack for powering this project. The battery comes with X360 connector, which I have some extension. So I am connecting this barrel jack to this barrel socket, and the project is powered up. Here, this fourth servo motor is a continuous rotation servo motor. That is, it's rotating, so we can also rotate in counterclockwise direction, and we can stop it. Okay, that's done. So let's move to the next servo motor. So that's the middle one. This middle one is also running. This potentiometer controls the 2 servo motors connected to the single channel. We can also see the positions of the servo motors in the OLED display. You cannot find this feature with usual servo testers. We extensively used this servo tester for the robotic arm of our rescue rover project. I have made a complete video on this project. If you are interested, please check the video linked in the I button. That being done, so let's disconnect all of these components from this setup and move to our next demonstration. Say you want to use a joystick in your project for the first time, so you want to test it out. For this demonstration, we are going to control these servo motors with the joystick. This time too, it is saving us a lot of time with the setup of these things you are seeing on the board. So first of all, we will have to remove this small jumper, which we will actually cut off the power for these potentiometers. Then we will connect this joystick to the Arduino. So we are connecting its 5V and ground to the Arduino's 5V and ground pins. Var X to the A0 pin and Var 1 to the A1 pin. Then let's connect the servo motors. We will be using port 1 and port 2 for the X-axis and the Y-axis servo motors, which will be controlled by this joystick. And then we will have to just upload the code. Like before, the code will be provided in the description. Now we have our code uploaded in the Arduino Nano, so let's power it up again. Okay, so here we see in the display the Var X and Y val are actually showing the analog readings from these potentiometers, and the servo 1 and servo 2 are actually currently written in 90 degrees. So as I move the joystick, the servo motors are changing their positions. Oops, I have connected the continuous rotation servo motor. Sorry for that. I have to actually connect a fixed position servo motor. So that is it. So it's currently set in 63 degree. So let's move the joystick, and the servo motors are changing their positions. That being done, we will proceed to our third demonstration. Again, we will have to disconnect it from the power and remove those servo motors. Let's say we have got this new temperature and humidity sensor in our workshop. We want to use it in a project, so first we need to get used to it individually. This time too, we have all the setup for display and power wiring done. Just we will have to attach the power and output pins. After uploading the code and powering up the board, we are good to go. So first of all, we will upload the code. Now we are done with uploading the code. Let's wire the DHT sensor with our board. So from 5 volt and ground are going to Arduino's 5 volt and ground. And we will be using digital pin 2 for the output of this sensor. Since we have the code uploaded, we can actually see the readings from this sensor just by powering up. Now you can see that here we get the readings from the sensor, that is temperature is showing to be 32 degrees Celsius and humidity is 89%. This time too, you just observe that with all this setup being done on a board, we can promptly use any sensor or other modules to our project, and it just too little amount of time and effort. Let's summarize what we have learned in this video. Having a permanently soldered board like this saves a lot of time and effort for people like us who works on electronics and microcontroller projects. Let me know in the comment what do you think about this useful tool. If you have any suggestion or confusion regarding this board, also write it in the comment. You can also start building your own board with the features you frequently use. If you find this video informative, please do like and share the video and subscribe to the channel. Thanks for watching the video up to the end. I will catch you in the next video.